Next example is intersection of two circles. It's a distance method. So the determination of a intersection of point using the distance method utilizes two sides of a triangle created by the radii of two intersecting circles. The third side of the triangle can be computed from known coordinates of 2 points. So here's the example: is we have x of a, and y of a, b, x of b, and y of b. We know those 2 points. We have specific radiuses, radius at the point from point A and radius b from point B. Now, they don't have to be the same radii, they can be 2 different radiuses, but they intersect on point P1 and P2, for example. Now, when we connect the line A to B, then we'll have a known length and we'll have an azimuth. We also just created 2 mirrored triangles, okay? So what we're now doing is using those radial values and known points, then we can solve for the triangles, and then we can solve for the x and y coordinates at point P. So again, it gives us an oblique triangle of ABP. So these triangles here, or the north triangle or south triangle, however you want to look at it. All right. So the first thing that we want to do, shocking enough, I know, is we're going to solve for the length of AB, and we're going to get the azimuth of AB. So this is our line AB, and then we'll get the azimuth. From there, we're going to use the law of cosines because we have an oblique triangle. We'll have a length, a length, a length that we've known, and we'll have an angle. We can also figure out, from that angle, we can figure out the, when we have these lengths, we can figure out an interior angle total and then divide it by 2, okay? So we'll rewrite the equation to solve for the angle at A, okay? There's our triangle. So the first thing we can do is we're going to solve for the azimuth from A to P, or I'm sorry, the azimuth of line A to P for either point 1 or point 2, okay? Or I mean, the last thing that we'll do is solve for the azimuth of line of point 1 or point 2, okay? Now, the decision to add or subtract of the angles depends on if you want to do the top one or the bottom one. You just have to be aware of your diagram and how it looks. One answer will make sense and one answer will be discarded, okay? There are no solutions if the length AB is greater than the sum of the radiuses A and B. Now, the reason is that means the 2 circles won't touch. And the possible coordinates at P is, again, using the latitudes and departure with a known point and adding the values to the x of A or y sub A, okay? So here's an example. We have the x and y coordinates at point A here, and we have the x and y coordinates of point B there. We have radiuses at A and radiuses at B. So we've got 2851.28 x of A and 299.4 y sub A, okay? And we have x of B of 3,898.72 and 2,870.15 for the y sub B. Now we want to figure out the length between A and B, so we're going to use the changes of x and the changes of y, and then we'll figure out the azimuth of A to B. All right, so the length is, here's my change of x squared plus my change of y squared, and I get my, oh, I didn't solve that out for you, and then I use my azimuths from my x to get my azimuth A to B. So the change of x over the change of y. Notice that the values are positive and positive, so this azimuth value is 22 degrees, 10 minutes, and 5 seconds. We're going to figure out the angle at A. I'm sure I'll get back to actually telling you what the length of AB is in a minute. We get the angle at A using the law of cosines. We know the distance here, so we can solve for the interior angle. So we've got AB, and there we go. There's our length of AB, my bad. So it's 2,775.948. That's the distance from this point to this point. We have the distance from AP. Remember, AP is just going to be our radius at A, and BP is going to be our radius B. all divided by the distance from AB and AP. So the angle here, and it's half, here is half my angle, is 31 degrees, 36 minutes, and 53.6 seconds. Now, the azimuth of the line AP, whether it's this AP or that AP, depends. It's either, if it's the azimuth AP1, we're going to add our angle. So we know the azimuth here, we add the angle at the angle A, or we're going to subtract the angle A. So we have 22 degrees plus 31 degrees, 36 minutes, and 53 seconds, and we get an azimuth of 53 degrees, 46 seconds, and 59 minutes. And the other one is going to be a negative value. If I subtract them, I get a negative value. That means that the picture isn't drawn perfectly, so that means it's going backwards, okay? So if we look at our not law of science, if we look at our departures and latitudes, we can figure out using the 53 degrees when we added the values. Our azimuth A to P1 is 53 degrees, 46 minutes, and 49 seconds. So we can find that the x of P is going to be 4,464.85. I kept telling you it was feet a minute ago. It's actually meters. That's what happens when you don't carry your units with you. And the y's value, y sub P1, is again the y at A plus the distance, which is going to be our radius from here to here, and the cosine of our azimuth from A to P. Okay. Now you can solve the other one. You can actually use the 9, so it's going in the opposite direction. And you can solve for the x of y and the x of P and the y sub P. And these should have been 2's. Oops. So, all right. Now, you also do an arithmetic check to make sure from the solution B. I'm not going to show that here, but you could do the same thing from that triangle on the other end. All right, we're going to go ahead and stop here and go to the next example.